Okay. Hello, everyone. Yes, welcome to the second session of Initial C++. See a few familiar faces, so hopefully this won't be completely alien, but again, we're really on the beginning sort of parts, and I will take you through the wonderful world of, well, C++, of course. So let's move on. So a quick little bit about these sessions. Obviously, this is indeed an introduction to the language. So, if you don't happen to have any existing programming knowledge, this should work out okay for you. It's basic language syntax. Of course, if there is anything you don't understand, please just stop me and raise your hand, whatever, let me know, and something that's not clear can be explained. Obviously, you're all here to learn. I'm here to explain it. So if you're not following or it's too fast, whatever, feel free to just raise your hand and let me know. So obviously what we do is a mixture of talks, which is obviously me standing here rambling at you, some class exercises, so you'll have a couple of those today, and then there is, of course, some homework. So obviously no one's forcing you to do the homework, but it's the best way to learn really is by doing. And I do thoroughly recommend having a crack at the homework. Of course, we have the Thursday sessions. Unfortunately, I was also off ill last Thursday, but I'm feeling much better this week.
Is this your fault? Have you given me your germs? Is that what it is?
Maybe that's what it is. I don't know.
That's all right.
So this Thursday, you can expect me to be there, and I can help as usual. It doesn't have to be the homework if you show up on Thursdays. You're quite welcome to bring any kind of C++ code you'd like help with, a personal project, something from HackerRank, whatever. There we go. Obviously, we're not going to be able to turn you into an expert overnight. That's one of those things that comes with time. It's like is it the 1,000 hour, or the 10,000 hour rule, or something like that? The 10,000 hour rule. That's the one. Yeah. If you want to get into this, you just have to put the time in. Really. And if you're a complete beginner, it might take you a bit longer. If you already know different programming languages, you might find it a bit easier. Everyone works at their own pace. Put the time in and you'll reap the rewards. But obviously, we're going to try and give you what you need in order to get yourself going. So, as ever, our obligatory feedback slide. We do love to hear from you. Any thoughts you have regarding the lesson, anything you'd like us to do, any recommendations, whatever you loved, whatever you didn't. We love to hear from you, and one of the best ways in which you can get in touch with us, or indeed, a number of us, our assistants, is through this wonderful instant messaging program called Slack. So all you have to do is register. It just requires an email address. So you head over to slack.cpp.al, Alpha Lima at the end there, and you feed it your email. It will send you one. You click the link, you register. You can then hop onto the Slack. We don't own the Slack. It's not ours. We just have a channel on there. So once you're in, you will just join a channel called CPP London Uni, this hash CPP London Uni. And then you will be with us. So last week, Tristan covered, the initial introduction to C++. He did some very, very simple code. There was a little bit touched on in terms of types, the type system in C++. So for example, an int is a type, a string is a type. So that's the type. That's what we call the type system. And we also looked at defining and calling our own functions. Obviously, a big part of almost any programming language is that you will create functions, because it gives you a way to write some code once and then reuse it over and over by calling that function, by running that function that you've defined with that piece of reusable code. And so this week we are going to, first of all, just have a little bit of revision. So go over the homework from last week, I believe, right, Tristan?
Sorry?
The revision's effectively the homework,
Well,
right?
we're going to have a bit of a refresher on functions and types.
Perfect. Okay. You're going to be introduced to using variables. So from the initial lesson last week, there was something of that. We're going to explain it to you in a bit more depth. You are going to have a look at passing variables to functions, so how to sort of put data in and get data out of your functions. We're going to look at if statements. So that's literally a statement that just says if, and it lets you have some sort of conditional execution. If the statement is satisfied, do this, otherwise do that, or potentially do nothing. So let's just revise types really quickly. So at its core, a type is a way of assigning some meaning to a piece of data. So for example, if I have the number 5, that's most likely an int. So the type of that number 5 is integer, right? But equally, it could be a number that has a decimal place. So it could be considered 5.0 or 5.4. That would be a float or a double, which is still a numeric type. Obviously, an int or an integer is numeric, but it doesn't have a decimal place, whereas a float or a double does have a decimal place. Obviously, you can convert between those two, but they are distinct. Does that make sense to everyone? Excellent, okay. So by looking at the type of a piece of data, so my int x equals 5, I can see that because it's an int, because I know it's an int, then I know that the only thing I can store into it are numbers. Not just numbers, but whole numbers, right? I can't put 5.4 into an int because, again, it doesn't have a decimal place. That would just round down to 5. In fact, because of the way computers work, they don't do bankers rounding, as you might be used to. So even 5.9 would round down to 5 in an int. Does that make sense again? I'm hearing, yeah? Okay, all looking good, cool. And obviously it means, I can't put a string into an int, right? I can't put hello into an int because hello is obviously not a number. And if you want a sort of a nice way of thinking about it, it's like PDF files or MP3s on your computer, right? I can open an MP3 in my audio player of choice, Windows audio player or iTunes. That can play an MP3, but it can't play a PDF, right? Because a PDF isn't audio, it's a document. I would use something different for a PDF. It's a different type, right? This is what we're saying by types. The type of the thing identifies what it is, what it can be used for, what it does. So a PDF is for documents, and MP3 is for music. And this is quite important. So C++ is what we call a statically typed language. So in other languages, i.e. not C++, they might let you change the type of some data. And what that really means is you're just deleting whatever it was and replacing it with something entirely different. So for example, in the PHP programming language, I can have a variable called x, and initially it could be 5, and then later on I could just arbitrarily decide, no, I'm going to stop using it as if it were an int, I'm going to turn it into a string. And PHP would let you do that, but in C++ you can't. So once I create an int, it's always going to be an int. If I need a string, I would have to create a new variable for that string. And we'll get into that a bit deeper later when we go into variables. Consequently, every piece of data that is in your program must have a well-defined type, be it an int, a string, a double, etc. It must be concrete. And as I said, it does not change. For the duration of the entire program, it will always be that thing. And the reason that C++ does this is because it gives us safety. If I go back to my PHP example, say I do decide that my int 5 is going to become a string, well, it will let me do it, but then I might forget that I switched it to being a string, and I might then pass it to a function that wants a number, and then it's going to run, and then when it tries to use it as a number, either something extremely weird is going to happen, or it's just going to throw an error, and my program is going to fail. Either way, it's not going to be what I want. Now, in C++, if you attempt to do this, it's just going to refuse to build the program. It's going to say that your object is already, say, an int, and you're trying to turn it into something it's not. You're not allowed to do this. Please go and fix it. that gives you some safety, right? It prevents you from making these mistakes. Or equally, if I think that a variable was an integer, but it was in fact a string, and I try and put an integer into it, C++ is again going to say, no, you can't do that. This is actually an int, it's not a string. Go and fix it. So you get some safety from this. It prevents you from shooting yourself in the proverbial foot. So let's have a look at some useful types, and I imagine this will go over most of what I've just said. So, int, as I mentioned, an integer is indeed a whole number. So, 0, 1, 5, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. There is, of course, a maximum value for an int. You can't just go off into infinity. You can't have like 99 quadrillion, 200 million, etc. There is a limit. That limit depends on the particular kind of computer that you are writing that C++ code for. So slightly confusing perhaps, but if you're using C++ and you're writing it and running it on, say, a MacBook Pro or a PC, then generally speaking you can expect this to be 2 to the power of 32 minus 1. It's quite a large number still. It's about 4 billion. So roughly 4 billion would be the maximum on a modern PC. If you had some tiny little, embedded chip, it might be much, much less than that. It might be 65,000. We then have floats. So these obviously are able to have a decimal place, right? So 3.142, 2.718, or even a negative number as well. This also applies to int. An integer could be a negative number. In fact, I was actually incorrect. If you are on a PC, the maximum value of an int would not be 2 to the power of 32 because it allows negative numbers, so it has to use some of its space, as it were, to encapsulate negative numbers. So it would actually be about half of what I said, about 2.1 billion, because it could also represent roughly minus 2.1 billion as well. Then we have a bool, a very, very simple type. It can only store true or false. So you can use it as a flag, or the result of some condition, right? It's only got 2 states. We then have what's called a char, which typically represents what we call an ASCII character. ASCII is a very old standard. It literally stands for the American Standard for Computer Information Interchange, and it is a conversion system for turning representing a number as a letter. So, for example, this 0 that's being printed on the screen, you see it as a 0. Internally, inside the computer, this is actually 30 in hexadecimal. I don't know what that is in decimal. So has everyone heard of hexadecimal and like bases, like base 16? Is that, yeah, cool, okay. So in base 16, inside the computer, 0 is in fact the hexadecimal value 30. But it knows to render it on the screen as visually as 0. And all of these letters, they all are obviously just numbers inside the computer. And there are these representations which we as humans can see. But additionally, within char, there's also some what we call out-of-range values. So, for example, the maximum value of a char, let's say 126. If I do remember rightly, I don't believe that there is actually a printable character for 126. So if the computer tried to render that number, you'd usually end up with like a little box or something because there is no actual character for it. And then we have std string. So this is a type that is part of the C++ standard library. That's why we have this std : because this is like a package. It's called a namespace really, but it's something that lets you organize your stuff, and C++ happens to organize all of the useful types under std. So we have this string, it lives under std. We use this : as a separator. And this represents some sequence of characters. For example, the string, hello. Everyone's clear what the term string is, I hope? A string literally just means some sequence of characters, basically. A sequence of chars, really.
What does STD stand
Standard, literally just standard. So it's one word but cut down to 3. And then we have another type called std-vector. So the word vector is a little bit confusing. If you know any mathematics, do not confuse it with the mathematical concept of a vector. It has nothing to do with it. A vector is simply a generic way of storing a sequence of types. If you know any other programming languages, this is better described as being an array. It just stores, a set of values, and it's able to make itself bigger or smaller depending on how many items you want to put into it. So, for example, if I have a vector of ints, then I can stick 4 ints into it, 1, 2, 3, and 4, and I can keep on putting more and more into it, and it will make sure automatically to grab enough memory to store those numbers for me. So, because obviously it has to, use some part of your computer's memory. It takes care of grabbing that memory and utilizing it for you. You don't have to manage it. You just say, okay, stick a 4 in there, stick a 5 in there. I can have a vector of floats. And then I can stick 0 in as the first element, negative 0.1 as the second, negative 0.2 as the third, and so forth. Does that make sense again?
Yeah.
Lovely.
Well, a vector as an array.
Sorry?
An array, a vector.
A vector is basically an array, yes.
Mm-hmm.
Yeah,
Yeah.
exactly. But it's dynamic. It's dynamically sizable, right? It will grow and shrink itself for you. So in the traditional sense of an array, usually an array is a fixed size. So if I have to tell the computer, okay, I want an array that's going to have 5 elements, and that's it. It can only ever have 5 elements. It can't have less, it can't have more. It's just 5. Whereas a vector, it's dynamic. I don't need to tell it how many elements I want. I just stick them in, and it grows the memory or shrinks the memory as needed.
Just within a vector, they all have to be within the same type.
Yes, they do. Yes. So the vector is what we call it's templated on a type, which really means that we have when we create the vector, the object, we have to tell it what we want it to be storing, and it can only every single element must be of that particular type that we want to store. So it's either all ints, all strings, all floats, whatever it is you happen to want. And this is what we call an example of a generic type, right? Because even if I want to store ints, I'm still using vector. It's just flexible on the type I want to store. That is obviously a form of generic programming, because no matter what type I want to store, the vector is able to handle it. It's the same code that's going to run, but it's able to cope with all these various types. That's generic programming. So, bit of revision on functions now. Oh yeah. Sure.
Vectors as its type.
Sorry, can I?
Absolutely yes.
Yes, a vector can take a vector, but it would have to ultimately end in some container type. So you can't have a vector of vector, because the inner vector still needs a type as well. So you could have a vector of int. That's like a 2D array, for example, right? It's in 2-dimensional. Yeah.
Right. So when you say it's flexible, can take anything, do you still have to declare specific
Yes.
type? So you cannot put an int and then in the same vector put something else?
Correct. So when you create the vector, you have to explicitly state in your program what it's going to store, and then the only thing that you're going to be able to store into it is whatever you said you want to. So, a function is, at its essence, some set of instructions. It's some code that we write, which we can then call. So we can run that function from somewhere else in our code, right? And that function just represents a sequence of operations that may or may not take in some data, some arguments as we call them. It may or may not return some data, depends on what you want it to do, obviously. But that's reusable because I can call it 5 times, and each time I do, it's going to run that same code with whatever I've given it. They are also known as subroutines in some other languages, or procedures. Methods is close. This is usually referred to in language. The word method is generally used in languages that have classes. So Java, for example, is something called class. In Java they use something called a class, and they have methods rather than functions. They operate basically like a function with slightly strange behavior. We're focusing on the simplest form, which is just a normal function. And as I said, you can give a function 0 or more pieces of input data. And we call these parameters. So a function can take 0 or more parameters, and I wish I could see a preview of what's coming next. Yeah, let me just skip back. Oh, that's fine. So a function can take 0 or more parameters, and just as I was saying with the type system, when you create variables, each parameter must also have a type. And when we call the function, when we're using the function, we must make sure that the parameters or the arguments we pass, so we call them when we're calling it, we call them arguments. So we use arguments fulfill the parameters. The types must match. If I have a function that takes 2 ints and I call it, my arguments must also be 2 ints. I can't swap that out for strings suddenly. I would need to write an entirely new function if I wanted to do that. And a function can optionally, i.e. if you want it to, return a value. So when you call it, it can take some input, if you give it some, or if it wants some, and it can do some processing, whatever it is you want it to do, and give you back something in return. Maybe a function called add would take 2 and the numbers 2 and 3, and it would return 5, because what that function's doing is adding numbers together. So, when we are writing a function, as I've said, we need to specify what the type of each parameter it's taking actually is. Each of the parameters may also have a name, and generally you would most likely want it to have a name. If it doesn't have a name, you can't use it. The name is literally what we refer to it by. So int x, right? If I just type int without the x, I have nothing to refer to. Whereas if I have int x, then I'm free to return x times 2, right? Which is going to make the computer multiply whatever is in x by 2. And as part of creating our function, we do also have to specify the type of what it's going to return. So if it's going to return an int, we will have to specify that, and we'll get into the syntax of how to actually do this in a second. If, for some reason, your function is not going to return anything at all, we use this special language keyword called void, which just means the absence of anything. So we have this magical special keyword here called void. And for historical reasons, which is mainly because of C, when you create a function, sorry, what's the best way to word this? When you want to use a function, you must have first written what that function does higher up in your source code. So imagine I have like a text editor, then I can't call a function at the top of the file and later on only then say what that function is. I have to first tell the compiler what my function is, write out what it's going to return, the arguments it takes, all the code that it's going to run, and then later on I'm then able to utilize that. I can't swap the order. Does that make sense? Good. So.
Is that the compiler literally?
Yes, exactly. The compiler processes your source code, your code from the top down. So, in order to define a function, the first thing we have to write out is the return type, i.e. the data it's going to give back, if any. And then we write the name we want to give the function. So if it was going to add 2 numbers, I'd probably just type the word add. It can be whatever you want. The computer doesn't care. The name is purely for you to refer to it and read it and understand, hopefully understand from whatever you've called it what it actually does. And then after that you define what parameters it's going to take in some parentheses, some brackets. Finally, after that part, we want to begin writing what's called the body of the function. The body of the function being the bit with the actual interesting, code that's going to perform whatever actions you want this function to perform. And in order for the compiler to know where that is, you have these opening and closing curly braces. So after we've done this first bullet point, we then write an opening curly brace, and we can start writing our code to do whatever we need it to do. And once we've finished writing whatever we need it to do, we then just close that off with a matching closing curly brace. So you can generally see in C++, it's similar to the logic you would expect from mathematics. If I've got an opening bracket, there's got to be a closing bracket somewhere. If I have an opening curly brace, there's got to be a matching closing curly brace. Make sense? Cool. And if it does happen to return a value, then we must use a return statement to give something back. So for example, if the function returns an int, maybe I want it to just return 4, so literally writing return 4 will do it. You do have to be careful with this. If you forget to do it, your program will still compile. Usually, the compiler will tell you, oh, you probably made a mistake, but it won't prevent you from running the code. If you do run the code without returning anything when it's supposed to, you will most likely crash or get something very, very weird.
So what does return mean? I mean, it creates a new variable somewhere that has that value?
So inside the computer, yes, there is this magical space where the return value is written. So when you call a function, there's automatically a little bit of space allocated for whatever object you're returning. Then when it's returned, the caller of your function is free to use that value however they like. And yes, as I was saying, it's always a mistake to fall out of your function if it doesn't have void as the return type. So if it has void as the return type, that means it doesn't return anything. And then of course, you won't be able to compile, because if you try to return something, the compiler is going to say, well, you told me this function doesn't return anything. Why are you doing this? On the other hand, if you say it does return something, you say it returns an int, but you forget somehow to write a return statement, it will compile, unfortunately. This is also for historical reasons. Sadly, we can't fix that one. It will compile, it will run, but you will get weird behavior. Most likely, your program will just crash. You will fortunately get a warning these days. The compiler will be like, oh, I think you're wrong. And it will notify you that you have probably made a mistake and need to put this in.
First, followed by first define a function, followed by its parameters. Obviously, when we declare its arguments, then we call a parameter. How is it interpreted correctly?
Sorry, what's your question?
So when we declare or define a function,
Yeah.
The list is arguments, and when we call it, it's parameters.
So when you're creating a function,
Yes.
we refer the terminology. So the question was, are you asking what the terminology is, basically?
Yes.
Okay, so the question was, what's the terminology for parameters versus arguments? So to be honest, nobody really gets worked up about this.
To be correct.
But just if you really want to be correct, when you're creating your function, we refer to them as parameters, i.e. what it's going to take. And when we are calling the function, we refer to them as arguments. It's what we're going to give. But most of the time you'll hear people just use the word arguments all the time. It's most common. Yes, question?
Sorry, just returning to the return statement. If you had an example of a function that's just adding two numbers together, for instance, what would be its return statement?
I mean, it depends on how you...
Slide, is it like
Oh, is the next slide? Okay, we'll just move on to the next slide then. It's going to answer your question. Oh, yes. There is a special rule for the main function. So everyone's familiar with main, right? Yeah? No? Okay, so obviously this isn't just a C++ thing, this is fairly universal. Your program needs what we call an entry point, right? There needs to be a function that has to be the very first one that will get executed by the computer, right? And in C++, that function has a universally recognized name, a special name, and that name is main. So if you create a function and its name is main, that is automatically recognized by the computer. It's like, that's the one I need to call to start your program. It's the entry point of your program. And there is a special rule for this, which is that even though main must return an int, due to magical rules that were, the flick of a pen years and years ago, it was decided that you don't have to do a return statement for main. If you don't, it will automatically return 0. This only applies to main, and I highly recommend that you just ignore it and explicitly write return 0, because it's just good practice, right, to make sure you return something. But technically you can get away with it for main. But, yeah. Okay, so let's have a look at a function and pick it apart. So we've decided we're going to write this all on one line. It's a pretty short function, so that's fair. Normally it's nicer to kind of break it up and indent it, make it look pretty, but
There are only so many lines on a slide.
there's also only so many lines you can fit on a slide. So we'll pick this apart, right? Or actually, no, let's see if anyone can take me through the syntax before I just give it away. So the first part, the int, what does this mean?
Integer.
It's an integer, correct? What's the meaning of int in the context of this function? What does this signify?
Right.
It signifies the return type, indeed. So this function is going to return an int. Add is the name, perfect. Add is the name of the function. This is completely arbitrary, right? We can put whatever we want here, but obviously given what it does, it makes sense to call it add, because when I'm using it, I can tell what that does. So then the next part, right, we've got this opening bracket and this closing bracket here. So what's this first bit, this int I?
Parameter.
Indeed, it is a parameter. So this is our first parameter, and then obviously we have a comma. So this is obviously a separator, right? This is separating one argument from another. We then have int j. So obviously, as you can imagine, I can keep on adding commas. So I can have another comma here and stick another argument in. I can keep on going. In this case, I only want 2 arguments. So after the first one, do a comma. We have int j. That is our second parameter. Make sense? Yes?
Can I add something?
Go ahead.
When I'm doing this parameter listing, can I do int I, comma j, or
No.
I have to be
So the question was, can I do int I, comma j, i.e. skip the type of the second parameter? And the answer is no. You must specify the type of every parameter. So we have I as an int, j as an int. You must specify it. You can't skip it and allow it to assume.
so there's no listing.
No, correct, there is not. So then obviously we want to now have our body of code that's going to do the add operation that we want. So we first have this opening curly brace here. Should we get so I can use this as a laser. Does it? Oh. Okay. The screen just absorbs the laser. Okay. So we have then our return keyword, this language keyword. This is what we're going to return. And very simply, we're obviously just going to return the result of I plus j. So whatever I is gets added to j, and then we're returning that back to whoever calls us.
What if I was a string? A string can be a number as well.
No, a string can't be a number. A string can store a sequence of digits, i.e. it looks like a number to us, but as far as the computer's concerned, that's not actually a number.
In I, but I was a string, it wouldn't convert it.
No. No, so
The way to think about it is that the digits 1 and 0, right, that's a string which has 2 characters, and those characters will happen to be 1 and 0. That's distinct from the number 10 as like an abstract concept of 10.
So the way to put it is that if I have a string with 1 and 0 in it, it's 2 char values that happen to render on your screen as a 1 and a 0, but it's not actually the number 10 to the computer. Now there are languages out there like, again, PHP, which like to do automagical conversions for you, and it lets you have strings with numbers in, and it just magically converts them into actual numbers. Now you can in C++ take a string of digits and have it convert them into a number, but you have to call a function that will take the string of digits and convert them. You can't. They don't just magically change. You have to call a function to do it. So.
Sorry, well, why does that not sort of read as like return I plus J is doing part of the function inside of the return?
Yeah, you could look at it like that, yeah. So in C++, an entire statement is whatever you write delimited by a semicolon. Right? This is your terminator. So when the compiler looks at this, it's going to have to evaluate all of the operations that are in this statement before it calls return. So it's working right to left in a way. So it's going to look at, okay, J plus I, do that, then return whatever comes out from that operation. So the name of it is add. It's returning an int. It takes 2 ints, that's these two here, and that's it. This is what we call a comment, right? The computer does not care about any of this. This is just for people to read and rely on. It's not part of the actual code. So we've got a new function, which we're going to call print. So void, what's the meaning of the void again?
Doesn't return.
It has no return type. Oh, sorry, it has nothing to return. So we put void because we're not going to return anything in this case. We have decided to call it print. And it's going to take one argument, which is this float. And then, of course, we're using the standard library's class, we'll call it a class, for printing to the screen. So cout is what you use to print to the screen. And cout just so happens to use this strange-looking shift operator. You can think of it as like injecting this stream of data that it's then going to print to your screen. So std_cout uses this to recognize when you're telling it, okay, here's what I've got for you. So the first thing we want it to spit out to the screen is f, which is our float. So internally, it's actually going to take f, which is a number, and it's going to convert that number into a sequence of ASCII characters so that it nicely prints on your screen. And then after that, we're going to pass it a single character. This /n is a special, what can I call this? We call it a character code. So this has special meaning. It's telling the compiler, the C++ compiler, I want you to omit the numeric value for a new line. So when you press enter on your keyboard, you get a new line in Microsoft Word. This is how we as programmers represent a new line as something you can see on the screen. But inside the computer, that gets converted into what will actually visually produce an actual new line on the screen. Make sense? Cool.
How does it interpret cout? Where is it sending it to?
So it would depend on what you're running on. If you write this program on a standard Windows or Mac computer, it will print it out to a command prompt or a terminal, depending on what you like to call it.
Cout some sort of character output.
White text on a black screen.
Basically, yeah, print out on your terminal program.
What's the STD count again?
So
Sorry?
std_cout is part of the C++ standard library, and it's what we call it a class. It's basically it's a thing that we use to emit data to the computer screen.
I think you asked about the namespace.
Are you asking about the std part?
Yeah.
Oh, this is what we call a namespace. So it's like a way of grouping things together, and in the C++ language, std happens to be it's an arbitrary name, right? Years and years ago they might have decided to call it the whole word standard instead, but they felt that was a bit long to type, so they shortened it to std. And everything that the C++ language offers you for printing to the screen, storing strings, etc., they all go under this std thing. You too can create your own versions of these and store your own stuff. It's a package. It's like packaging, right? It's a way of organizing stuff under a single sort of hierarchy. So, was that clear? Yeah. Sorry, question.
So I was just wondering about the rule you said that it executes from right to left?
It doesn't execute from right to left. It's the compiler will effectively evaluate it from right to left.
So in the other case, does that the operator?
Oh, sorry. Yeah. So I'm slightly confusing you. No.
I think a better way of thinking about return is that it's like a command. It's saying return something, and this thing is like that calculation, that expression.
Yeah.
So return, and then it looks at everything up to the semicolon and evaluates that.
Yeah.
And then that's
It's
the thing that gets returned.
yeah. C++ isn't universally like a right to left thing. It's not all like the. Yeah, maybe that's not the best way to think of it up here. It's an order of operations issue though, right? It first has to evaluate what we're doing to I and j, then it will finally evaluate what it needs to give back. Maybe that's a better way of thinking of it. So in the case of this, it's first of all going to spit out f, and then it's secondly going to spit out the new line to the screen. So maybe forget about the right to left. That's probably not the best way to explain why. Because the original question here was like, why doesn't return just give you back I and ignore this part? Obviously, that wouldn't make any sense, right? You obviously want it to do this first and then return it.
Briefly, in the second case, is the return type void rather than string because the new line is void?
So no. So the reason this is void, right, is because what we're doing here is we're calling cout with some data, and then cout returns back to us, and cout isn't actually really returning anything to us either, right? It's just we're spitting stuff out into the screen, but there is nothing to return, right? This is performing the operation of sticking stuff on the screen, but the function itself is not returning anything. Yes, Michael.
I think maybe the best way to visualize it is after cout, the string is gone. It's never coming back.
So then that's void.
Yes.
Disappeared into the void.
Into the void, indeed. So of course the name is print. There is no return type. We said void, which means there is nothing to return. And the parameter it takes obviously is just this one single solitary float. So now we need our main function. Again, this is the specially recognized entry point for your program. So the computer looks for this and says, okay, this is where we start your program from. And as we can see, it's returning an int. We have the curly brace to open up what we call the body of the function. And now we're going to call our functions. So I want to print pi to the screen. So I literally use the word print because that's what it's called. And then of course I have these parentheses so that the computer will enter into the function and call it. And I'm going to give it 3.14f. So obviously the first thing that cout is going to see is, well, 3.14. So on your screen you will see 3.14, and then obviously there'll be a new line. You don't see a new line obviously, you just see text on a new line, but we haven't printed any new text yet, so you wouldn't physically see this, of course. You can't unless you have a flashing cursor. If you have a flashing cursor on your screen, you might see because the little cursor moves down. Is that clear? Yeah. Oh yeah.
A very quick suggestion. If there is a mouse, use the pointer. Because I'm thinking that you stream
Yeah.
as well, right?
Yes, that's
you will
true.
obviously see where
Let's.
you're pointing at.
Oh no.
Keynote doesn't do this.
There we go. Okay. Subtitles is quite nice actually. So laser pointer. Okay, yes. So we've got the 3.14 here, which will then be passed into f. F's going to get used here, and then we end up with our new line. All good? Cool.
What's the F for after 3.14?
So we specify f to tell the compiler that we want a float and not a double. If I don't put the f, I would get a double instead. A double is just a type that can store a longer decimal place. So if I use a float, there's a smaller limit on how many digits I can have after the decimal place, whereas a double can fit more after the decimal place. And then we're going to have main return a value, obviously. And what it's going to return is whatever comes out of adding 3 and 4. So we're going to take 3, that's going to go into I. We're going to take 4, that's going to go into J. So add is going to perform 3 plus 4, and obviously it's then going to return the result of that, which is 7, which then means that main is going to return 7 because it's going to get back 7 from add. So that's what it will be. Yeah. And then of course we close off the body of the function. Once the function's got a return statement, you can't stick more code after a return statement because obviously it would never run. So once you've got that return, you're done. Okay. So let's have a look at last session's exercise. This is what you gave them last week, right?
Yeah.
Yes, cool.
What I left people with last week.
Hmm?
It's what I left
Oh, it's the homework.
everybody with last week.
Got it. So, you were tasked with writing, modifying your Hello World program with a function. You were meant to create a function that doesn't return anything. You wanted to call the function Hello CPP London Uni with these underscores. And then obviously no arguments, so just nothing between the parentheses. And it was supposed to print out Hello C++ London Uni. And then all you had to do was just call that from your main function. So here is the solution. First we create the function. So again, no return type. Hello C++ London, CPP London Uni. Open up the body, and you can see now this is not on one line. We've decided to format this nicely. We could stick it all on one line, but obviously it's not as readable. So we've split it up for the benefit of us humans to have an easier life. So we open up the body of the function. Again, we're using cout to print to the screen. And we're just printing out what was specified. Again, with this new line at the end, so that it moves the cursor down. We kindly close it off. Then have our main function, which will return an int. Again, entering into the body here with this curly brace. And of course, we're going to call the function. So we put its name. It doesn't take any arguments, so we just leave this obviously with nothing in it. And then of course, we return 0. You didn't go over returning from main and what that means, do you?
I can't remember if I talked about it last
I'll just
week.
briefly go into it. So in your main function, once your program is finished with everything it needs to do, when you return from main, your program will close, it will terminate. And to let the operating system know that everything was fine, let Windows know, or Linux, or whatever or MacOS, or whatever you use, we generally return 0. The operating system doesn't actually care. We could return 200. That is considered that something must have gone wrong. If you return something other than 0, it signifies something went wrong. But it's generally for the system administrator or user of your program to read, to investigate and care about. So if I return 5, then whatever that means is up to me. So I would probably include a manual with my program, and it will say, obviously returning 0 means everything's fine because that's what everybody does. If I return 2, then the hard drive failed. If I return 3, then I had some issue connecting to the internet. Whatever you want it to mean. But 0 is universally accepted as everything's fine. When you return from main, I'm specifically referring to. Yes.
So the /n for the new line, does it always have to be within the speech marks?
Yes.
It has to be. Yeah.
So unless you wanted to do what we did on the previous slide, and you could obviously do another set of these and then have it on its own, that would be a bit pointless, because obviously you're just making the computer do a bit more work. It's got to process the string, and then it's got to process a single character after it as well. So by putting it all together, it's faster for the computer to process. But you could do it that way.
I know it's the same effect comes from writing NL, I think? Or,
Yes, stood end L. Yeah.
Is it more common practice to just put /n?
So there's two reasons that we generally don't use endl. So endl doesn't just represent a new line. It also happens to perform what's called a flush of the object. So it doesn't really matter for cout, but it does matter when you're writing to say for a file, right? So if this was going to be written into like a text file on my hard drive, if I use /n, then the computer can buffer that, right? Because it might decide that it's not worth waking up the hard drive to spit the data out because it's got to seek to that on the platter and it takes time, right? If you use endl, that triggers what's called a flush, and then it forces the hard drive to wake up and seek and physically commit the data, which sometimes you might want. But if you're spitting out loads and loads and loads of very short strings and you're forcing it to make the hard drive do it every time, that might take a very long time. Whereas if you don't use endl, as you refer to, and you're just doing it this way, that's fine. It can then do what's called buffering. It can bunch it all up, and then once it decides there's enough data to actually wake the hard drive up for, it can then have the hard drive write all of that in one big chunk, which is generally faster. Okay, let's take a look at variables, and arguably we basically already have. So, obviously, if all we had were just functions that do static, unchanging stuff, it's probably not going to be that useful. You want to accept some kind of input, probably from a user, right? From the person using your program. At the moment, we haven't seen any functions do that. We just wrote our code, and it just takes values that we defined inside the code. Usually, you want the user of your program to be able to do something themselves. So for that, we need to use variables. And essentially, you've already seen one really from the function example, but it's basically just an item of data that has a name: string x, int y, float z. And again, as was said earlier, every variable must have a type. And whatever that variable is storing is referred to as its value. So if I have an int x and I set it to 5, its value is 5. If I have a string z and I set z to hello, then its value is hello. And of course, the nice thing about this is we can change that value as we go along. So x might be 5 1 minute, and then I might multiply it by 2, and it will become 10. Right? Its value is variable. That's why it's called a variable. So, to declare a variable, we write the type followed by the name, and preferably followed by what we call an initializer, i.e. an initial value to give that variable. So, for example, we've created a variable called myInt, and it's going to store an int, and its initial value, or the initializer, is 3 because it's equals 3. Make sense? Yeah? Okay. Now we're going to change what's inside it. We're going to change it to 4. Obviously it's a little bit pointless in this case to have set it to 3 up here because we never actually used it when it was set to 3. All we've really done here is initialized it to 3 and then immediately replace that with the number 4. But you get the point from that, right? You can change what it's storing. And now we're just going to print it to the screen. So obviously cout's going to get the number 4 because we overwrote it with 4. And then as usual we print our little new line just because it's considered good practice. And then everything's all good, so we will return 0. And then of course we close off the body of the function. Yeah? So, well, like I said, really, it's a variable called myInt, and its value is 3. And as you can see, we can obviously use the equal sign to change what is stored inside it. And obviously, because it is an int, the only thing that we are allowed to store inside it are integers, numbers. So, we can bring this all together because we can use the result, whatever a function returns, we can use that and store it in a variable. We can initialize our variable with it. And what C++ will do for us is it will check what we have stated the variable should be, so like int x, and then it will make sure that whatever is returned by the function is compatible, i.e. if my variable is an int, then the function I'm initializing it with must also return an int. Consequently, obviously a function that doesn't return anything cannot be used to initialize a variable. And just in case anyone is wondering, no, you cannot create a variable that is type void. It won't compile. You can't have a variable with the absence of anything, right? This is the absence of stuff. That doesn't make any sense. You can't have like void x. It won't compile. Wouldn't be very useful even if you could. So let's kind of put together the stuff we've seen so far. So we've seen this is our add function from earlier. You've seen this before. It obviously just does I plus j and returns it. We've got a new function called getName. It returns a string, and that string is just the name, the 3 characters Tom. And we have our print float function as well from earlier, which obviously doesn't return anything. And then we have a main function which we're going to use to demonstrate how to initialize from calling a function. So first one is we have a variable called a. We're initializing it's going to be of type int, and we're initializing it with whatever add returns for the parameters or the arguments 3 and 4. So obviously a will get initialized to the number 7, right? 3 plus 4 is 7. We're now going to create an int b, and we're going to try and initialize it with the result of getName. Well, that's not going to compile. The compiler will tell you, nope, you can't do this, that's illegal, because getName over here returns a string, and you said that b is an int. Clearly, string and int are entirely different things. You can't do this. It's not going to compile. Then, as a third attempt, we'll create an int c, and we'll try to initialize it with, well, basically we're going to try to initialize it with the absence of anything, which again won't compile. The compiler will say c is an int. This doesn't return anything at all. You can't do this. And again, as I said, if I were to write the word void here, it would still fail to compile because you cannot create a variable with the type void, because the void just means nothing. I can't have a variable of the absence of any kind of data. And then as usual, we just return 0. Does that make sense? Lovely. So, obviously we've looked at creating variables. What about copying? So, as you saw, we use the name of a function to initialize it. We can equally use the name of an existing variable to initialize a new one. And of course, what we effectively have now are 2 separate variables, but one of them has copied whatever data was in the first. It's, imagine you have like a Word document on your hard drive. You could save a copy of that file on your hard drive, and if you edit one of them, if you edit one of the files in Microsoft Word, it's not going to affect the other file when you save. And this is the same logic, the same rules apply in C++. These copies are completely distinct from each other, i.e. if you change one, it doesn't affect the other. So, just to demonstrate it, using my sort of Word document allegory, we have an int a. This is like your first Word document file, and we set that to 44. We then create a variable called b. So this is like creating a copy of the Word document on your hard drive. But we and it's initialized with a, obviously, so it's got the same number, it's set to 44. We're then going to set a to 99, i.e. we're setting, you're changing the contents of one of your Word documents, if you like. And so, of course, b is unchanged, because b is entirely separate. It just took a copy of a at this point in time. So at this point in time, a is 44, then later, a becomes 99, b has not been touched, so it's still 44. Does that make sense? If you think of the chronology of how that's going to run.
What would happen if I changed, I want to change A to like 12.5 or something like that? If I need to add a float.
So if you did a equals 12.5, because a is an int, it will just round it down to 12. So if you actually wanted to save 12.5 into a, you'd have had to have declared it as an actual float.
But like, wouldn't that cause an error at the start? If like, let's say if I wanted A to start as 44 and I wanted to change it to 12.5.
No, because a float can have a decimal place. It doesn't have to have a decimal place. You could you can think of it as 4.0, right?
Oh yeah.
It's basically 4.0.
Doesn't it always round down?
Correct. It would always round down. So if I did 99.9 here, that would still just end up as 99. Yes.
Towards 0, it does truncation. So if you've got a negative number, it just gets rid of the decimal place. If you had like
Oh yes, that's true. So if it's negative,
minus
don't think of it as rounding up. It just chops it off, right? So if it was minus 1.9, it's still going to it's just going to be minus 1. It chops it off. That's the best way to think of it. And so obviously, yeah, we print it out. You get 44. Make sense? Yeah. Cool. So now let's look at bringing it together again and having variables interact with functions. So obviously, we can use these variables that you've just seen as input for the functions that we created earlier, which is obviously more interesting than giving them static values, right? And again, bear in mind, the function itself also is getting its own separate copy of whatever the variable happens to contain. i.e., if inside the function you modify whatever was passed, it does not affect the variable outside of it, right? However, it doesn't affect the variable the caller gave it. I'll go into a bit more detail in a sec once we get an example. And the name for this in programming lingo, we call it pass by value, because you're giving a copy. You're not giving what we call a reference. We're not sharing the variable. We're making copies. So we've now got a function called add1v1. It takes an int called I. It returns an int, and it's just going to take whatever you give it, add 1 to it, and that's what you get back. We have our add1v2. Doesn't return anything, notably. And again, it just does I equals I plus 1. It has no return type. And so in main, we're then going to have int a initialized to 3. And then we're going to create a new variable called b. And we're going to call our add1v1 with whatever is in a. So this is obviously going to see the number 3 over here, because obviously this is 3, so this becomes 3, so this has got the 3. This means it's 3 plus 1, so it returns 3 plus 1, it returns 4, so b is going to be 4. Does that logically make sense? You can follow that. Okay. Makes sense why b is going to be 4, yeah? Yeah? I've got some confused looking faces, so I'm not.
Is it still called B though? So you pass B by the function.
No, I'm not passing. No. So I'm not passing b.
One way to think of this, that I probably should have put on the slides, but one way to think of this is that if you look at the first function that's on the screen there, add1v1, it has a parameter int I. And you can think of that, if you like, as like a variable inside that function that just happens to be initialized by whoever is calling that function.
Yes.
So just as we saw on the last screen, or the last slide, that when you initialize a variable from another variable, it creates a copy. When you initialize I from whatever value you give it, that creates a copy of the given value.
So I is a variable that only exists inside this function, right? Nobody else can actually use this. Only inside these curly braces can we refer to I, right? It's only visible inside the function. And then here, where we call it, we are creating our own int b. B and A are also only visible inside the body of main, right? So B gets initialized to whatever add1 does, which happens to be giving it 3. So obviously it initializes its local variable I with the number 3, does the math, returns 4, and so B gets set to 4. So we have this variable B inside main, which is 4. So now we're going to call add1 v2, which is the second function here. It doesn't return anything, as you can see. And so obviously I inside add1 v2, because again this has its own, this is only visible inside here. It has nothing to do with this one. Even they happen to have the same name, but they have no relation to each other. This function can't see the other function's variable, and vice versa. They're purely internal to the function. Yeah. So what's going to happen is we take B. That's going to be 4. It's going to be that. It's going to do I equals I plus 1. So it's going to be I equals 5 basically. So then the question is, well, actually no, it's written there in the comments. So obviously B is going to be 4 still. It will be unchanged. Because all this is really doing is it's adding 1 to its own internal variable I, and then obviously we don't return anything, so that just gets thrown away, and it's as if nothing happened. So obviously this is basically a useless, pointless function because it doesn't actually do anything or achieve anything. Yes?
If it had returned something that would 5.
Yeah. So if it had, let's say we change that to int, so we change void to int, and then after I equals I plus 1, we did return I. Then obviously now it would be useful because it would do the same thing as this one. So you've basically got two functions doing the same exact thing in a slightly different manner, i.e. in this case we first of all increment the variable and then return it, whereas in this particular case it's just shorter and easier to read because we just do it all in one go. But yes, you could, yeah. And of course, sorry? What about ampersand, sorry?
That can change the flag.
Yes, if we were using reference variables, but we're not. Yeah.
Oh, you're talking about references. If you put ampersand on here, yes, that's references, correct. Okay, but don't worry about references, guys. That comes later. So now, oh no, back you go. Cool. So we have an exercise for you, so you can start putting this into practice. So crack open onebox.org in whatever browser you like, Firefox, Google Chrome, Safari, Internet Explorer, etc. And in your main function, we just need you to create a variable called first name. And obviously it needs to be a std string. Initialize it with whatever your name actually is, so John Smith or whatever, don't forget the quotes. Print that out using good old std cout. Again, don't forget to hash include at the top, string and IO stream. Usually you get some example code here and it will probably have done IO stream for you, so you'll probably just need to add string, but if you're not sure we can help. Then we want you to write a function called str_join, i.e. one that joins two strings together. Have it take two strings as an argument, return a new string which consists of both of those parameters or arguments joined together but with a space in the middle. The plus operator is what will let you do this, so you can join strings with the plus operator just like you can add numbers together. It works in a similar way. And then in your main, create a new variable named full name, which is the result of calling str_join with your first name and your surname. And if you need any help, don't be afraid to ask.
Also, this looks like a lot, but I sort of made it quite a big exercise for people. For people who you know, who've seen this stuff before and want them to sit there bored for a long time. But if you are new to all this, this might look like a lot, but you know, I don't necessarily expect you to sit there and just do it all. So if you can do the first couple of bits, that's really the important part of this exercise. And the rest perhaps is something you might want to practice when you have time. I'll retreat back to my sick beds, ladies and gents, but thank you all for coming tonight. Apologies for the
Not to worry.
last minute substitution, and thank you again for Oliver for taking over. And I will be back to full fitness in a couple of weeks, and I look forward to seeing you when I'm all fit and well and hopefully don't have coronavirus. All right.
Got everything? Oh, I can look after
Yeah,
it.
so just
I'll just leave the kit, yeah.
yeah, just bring it next to it.
Yeah, that's all. What happened to the other dongle? Not dongle.
Okay.
Oh no, never mind. You gave it. I got 'em. Yeah, that's it. Okay. I'll plug it up since it's not very useful right now. Later. Is anyone stuck in need of help?
Yeah.
Right, not to worry. Where are you stuck at?
Starting a function.
Right, okay.
For a string, just declare it as a string as str.
Stood cone.
Oh, stood. Okay.
If you look there, it's on the first bullet point. In the first bullet. You need to just fix the this bit. So you see here it's hash include and then the thing you want to include.
Yeah.
You only have to. It's one thing per line. So
Oh,
it's
I
hash
see.
include thing.
Okay.
Hash include thing. Hash include thing.
Okay.
And then you want a second one. Just make it. Yeah. Not to worry. And you won't now. First steering and operating. It's not really the creepy part of that. Oh, yeah, and then hash include string insert bio string.
That's the key from where.
And what was the person that is to?
So unfortunately, C++ doesn't just give you everything you want to use automatically. They exist in these files on the hard drive. So when the compiler runs, it grabs opens up the file with IO stream, and that contains a bunch of source code, which creates the C function. And then the string contains a bunch of source code, which creates the string.
Which does that. And then you call this separate function from the separate function.
Yeah.
Okay.
I
So what I try to explain to you is like the signature of the function, the housing function, how they are usually structured. And then within one function, you can like junction, but
Yeah.
always choose next.
Green, yeah, it's coming from red.
So,
Right. So,
the original.
oh, no, you've got one. So, the first one.
Don't forget the next bit. It's not something that I know in other languages, but it's working. Don't follow the language.
Yeah, you don't actually. So, I see.
I'm not really, I mean, I use PowerShell for work.
So then,
So,
what we do,
you can type on the string unless you want to.
I mean, yeah, that's just, yeah, please don't. Yeah.
So followed by the parameter list. So the parameters.
hey, main function. No, I think that looks fine.
That's the first one. You have to choose parameters.
Yeah.
I need to put in string as well.
Yes.
Yeah, sure. I think
That's
it's
usually the parameter.
David the first.
The parameter is what goes on the user. But again,
Yeah. Oh, no. So it needs to only take two arguments. You do all the fun stuff in the body of the function. Also, due to the rules of C++, you need to put this above your main function. You're going to be using it in there.
Why would that not take the same code at the end?
Because it's like it would compile with something. Your the link would be visual.
Yes.
So compile it with the definition and not say okay.
In your return statement.
That's the example. It's like but the link would be
Since it's one character, you might put it over here. Try it.
if you just put it as a comment,
You need to send code out as well.
your function doesn't
Yeah, try that one. If for any reason, just one quote single character. Basically, if you use single quotes, it must be one exactly one.
Within this one.
If you use double quotes, it is multi-line. So safe that. Example.
balance that equation. Should
Example running.
and do the process.
Okay, we'll just cut paste it over and then select all. Control X. Select all and paste.
So I put return.
Oh, you've got. I see what you've got. So you've got these pages. Everything has to go inside of that existing body of code. Yeah, that works.
Again, I just think that
Yeah.
again, we have to use strings names.
Oh, hold on. What's missing now? Oh, you just missing something.
Just the space in between.
The space needs to be a separate symbol.
So that's a start. So now what you need to do is create a variable with your last name,
What
and then you want to see out.
you see, for example, here under you know
Yeah.
that's
Yes.
right. You put it in.
Yes.
No, I think within,
Not sure if that's
No,
so you need to be a
That's your
function
variable.
above the name.
It's got to be above it.
This is what I call it. Meaning as a
No,
literal value.
and yeah.
This is a variable.
So you're not quite there. So your variable arguments, your parameters need to have type.
Yeah, that's what I was going to say. Was it just? But after that, but stood.
No, yeah, you have to do it. It's always the same. Existing. Yes.
Okay, nice.
String join A and B, return A plus
space plus a B. Yeah, perfect.
Also, I would like to ask, previous lesson, I've done this exercise. If I run, Thursday,
Mm.
So just
not everything appears
just
to be done.
What was it you need to do? If you get the exercise up, I can read it and see what you're meant to do.
The problem is we don't have, I think, the index. I'm not sure.
Okay, I don't remember what the exercise was, but if you bring it up, I can take a look.
So the problem I can tell you in here. This one works because it's outside. What is it? Yeah, this one it works because it's outside of structure or class. If I put the whole thing in a class, it doesn't work in the same way. And that's my problem.
Okay. Have you got that code? Have you got the code that doesn't work? I need to see it.
Class personalist.
Okay.
Person.
Yeah.
Personalist.
Yeah.
Now. So green is void. Over there it doesn't work. So if I
Yeah, but what's not working? So I'd need to look at the code that's not working to fix it. If you try and do the code again, I can
okay.
work with that.
And then you initialize it with the value of your name.
Am I supposed to see this one? No. First name. Not quite then, because this function's meant to join them up with the space return. You're not meant to print it out inside this function.
Oh, you don't print the spaces?
No, you do that later by using this function. So you just delete that whole line, or maybe move it. Well, actually, no, actually just leave it. Get rid of get the whole delete the entire line. Okay. Right. So what you want to do is return. That's what it said basically.
It starts off with
Right function string, which takes two strings and returns a new string which consists of the two inputs separate by space. So you want to return.
it's just in words. So it always
Yeah, and then so if you look, see that inner bullet point, the innermost bullet point, it says use the plus operator to join strings up. So you're going to join your first name up with the space. So what's the name of the variable? What's the name of that variable that's got your first name in it?
First name.
Yeah.
I just stream and see
And you use that plus operator, so now you need to put a space. Last name. Yeah, that's what you get the function done. So now the name. Oh, sorry, no. I see what you're doing. So you need to. So your function takes strings, right?
So
So
you
when you call it, you need to give it strings. No. Line 14. So your task now is to print out whatever your function returns.
Okay.
Let's see out. Well, you could, do you want to save it in a variable first? You can. Yeah.
How do? Oh, so that would save a variable. That's how you start.
I was just guessing what you want to do. You want to see just see out is what the simplest one. So you still see out.
Just see out.
Mm-hmm.
What does that mean? Right.
The thing that prints the screen.
Oh, run it.
No.
Nope.
So do you remember the thing we used to print the screen? Stood see out.
Oh, yes.
Yeah.
Yeah.
Use that little shift angle thing.
And now you've got functions, obviously you need to give two arguments, which is
So this counts as a console log, basically.
it's out. So now obviously you need some kind of strings to be there. The strings are the same as the JavaScript.
Mm-hmm.
No, you're calling the function just like you would call a function in JavaScript, that's fine.
Yeah.
So you just need to pass it some strings as the arguments.
At the moment, it's just
So it takes two arguments. So you've written Thomas, but you haven't. That's not a string. That's
Right.
That would be
Ah,
yeah.
okay.
Okay. And then finish off with semicolon.
change.
You need that for return as well. No, usually returns or have return code. Semicolon.
But yes,
Perfect.
group
Okay, give that. Yeah.
change. So white space, stream operator.
Perfect.
Beautiful.
Okay.
You go.
Stream operator is what you use for between CI.
You were here last week, right?
Yes,
last Tuesday. Yeah. PhD student. Yeah.
Okay.
You did get mine. Okay. Yeah, you did.
And then you
Yeah,
just
okay.
give it a literal.
Yeah.
You haven't come yet.
Could
There's something called while.
It's in Shoreditch. There's actually
While
C++.
while is very good.
No, it doesn't cover C++. You know what?
Well, at the moment.
HTML, CSS, JavaScript, and then going to React. That sounds like a lot. So that's just the front end, and then back end
Yes.
it goes on
So
to
just let's just do it.
Python, Node.js. Oh, we just basically.
I don't know. Finish it.
Oh, okay.
Such
That's cool.
So, what kind of stuff that be there?
We have-
Oh, yeah.
It's just like
It's
write a program.
So, sort of, so that's this.
Basic Paradigm, just not C++.
Yeah, no, I'm still not
if you
entirely
use it
sure
for
I just used to use programming and software. Is it?
Software dev, software engineering, it's kind of all below.
I might be able to do programming, but I definitely don't feel confident in setting up software.
I guess, yeah, to properly word it, like, software engineering, coding side.
Right.
You have to give definition programming is more like working with the line of code compiled.
Okay, I would put it the other way. It says you don't need for me, but then programming language is writing like this is programming. It's one function to do
Yeah.
kind of calculation.
Yeah.
Software is hundreds of functions packaged together, all of which work together. You know, it's a piece of software is like an app or something. That's what I think of it. But I know that technician. And then I think people talk about architecture, software, but I don't really know what that is. So
How are we getting on?
say that picture I have in my head is like a flow of functions.
Right, give me about one more minute. I think we need to.
But
See what else we got. Okay, I think we'll crack on.
So, and you need to put like the arguments that you
censorship overloading and getting double code.
Yeah.
It's just embarrassing.
Double code and stuff like this.
It's expecting two strings. I think one of them can start the whole thing miswriting it down as a single colon, so the whole thing was wrong.
All right. Since we've got about half an hour left, so we're going to have to crack on a little bit. So, first of all, the solution. So look away now if you still want to work on it. we have the function we needed to create called str_join. Obviously it needs to return a std string. We have the first argument, A, which is of course a std string. The second argument, B, which is a std string. You can call the arguments whatever you like. A lot of you sensibly chose to call it first name and surname. That probably is actually nicer and more readable, but you don't have to. This solution happens to just be A and B. And then of course we need to return A plus a single space. You could also use single quotes here, that's okay, but double quotes are equally as good. And then of course we need to then join the surname onto it as well. And then inside our main function, we're going to first define our first name, which is going to be Tom. We're then just going to print it out so we can look at it. We're then going to create a string which will hold our full name, and we're just going to join our first name up with, as you can see here, we didn't put our last name in a variable. You could have, that's also fine, we just chose not to. Really just to demonstrate how you can do this. So this one's in a variable, this one's not. And then of course we just print it all out, and you would see Tom printed out on this one, and then on a separate line you'd see Tom Brezza for the second one. Yeah?
What do you need the STD for? Use string.
For these?
Yeah.
No, because they all live inside the std namespace.
I've seen written string.
Oh. If you've been looking at examples on the internet, you will most likely notice they use a feature of the language which lets you omit it. And the way you do it is you write using namespace std. We don't do that because it's considered tremendously bad practice in any professional environment where you're writing C++. It's generally frowned upon to write this. The reason why it's frowned upon is because there is a lot of stuff in here, and very frequently people write their own versions of stuff that's provided by STD, and obviously if you happen to use this naughty feature, you end up with what's called ambiguous names, and you might end up using the C++ version of, say, vector or array or something, rather than the one you wrote yourself that you wanted to. So the whole point of this packaging, right, is that it keeps things separated, and when you start including this little feature, it throws all that away and you lose that separation. So we don't use it, and again, it's generally frowned upon to use it, so stick with having STD.
What does the include string?
Oh, so these are just files on your hard drive actually. So what the compiler does is it has a predefined, when you install a compiler, it has a predefined set of folders where it looks for what we call libraries. And so this is just a file with a bunch of source code in it, and that source code is what creates the cout object. And then there's another file called string, and that's the one that contains all the source code that will let you use string.
But actually didn't include the string.
It's including a file that contains a bunch of source code. So these are both files that are part of your compiler, and it opens one up, processes it, opens the other file up, processes it. This one is providing you with cout, and this one, string one, is providing you with, let me just use the laser. So the IOStream one provides you with cout, and the string one, unsurprisingly, provides you with the ability to use strings. So let's take a look at if statements, control flow, conditional execution. Probably the most important part of any program, right? The ability to do or not do something based on a certain condition. And yeah, it's essentially one of the most sort of basic building blocks of a computer, right? If you click on the start menu, it opens the menu. If you don't click on it, then it doesn't. And at its core, an if statement is going to test some kind of condition, whatever you decide that condition should be. And if that condition is true, then it will execute whatever is inside that if statement. And if it's not true, then it won't. And so the basic form of these if statements are as such. We have our, well, the word if, and then in the parentheses, we would write whatever the condition is. You probably wouldn't write the word condition literally, just whatever it's meant to be. An opening curly brace for whatever is going to be dependent on that condition. Whatever you need it to do. So this is just a comment. Again, this would be ignored by the compiler, but it's to signify where you would put your code. And then we close it off. So if whatever we were to put here, if whatever we put here happens to be true, then it will do whatever's inside here. So, for example, we could test if two variables are the same, have the same value, like x and y. We want to see if they're both equal, right? And in C++, to check if they happen to have the same value, we use this double equal sign operation, right? So if you only have one of them, that means assigning a value, setting a value. If you have two of them, it means comparing rather than setting. Yeah? So note that there are two of them and not just one. There is a corollary, which is exclamation mark and an equal sign, and this is checking that they are not equal. So again, this first one is checking they are equal, and this would check that they are not equal to each other. So obviously for both of these, you will have something on the left-hand side of these symbols and something on the right-hand side of these symbols, as you will see. There is a bunch of other what we call comparators, right? Comparison operators. We have one to check if something is less than something else, or if something is greater than something else. Basically, like you'd see used in maths for these ones. Check if something is less than or equal to something, or if it's greater than or equal to something.
There's no triple equal operator.
No, that exists in JavaScript, for example, but no, we do not have it in C++. The reason that the very reason that we don't have it in C++ is because we don't need it. JavaScript is not statically typed. Same for PHP. Because they are not, they have the triple equal sign so that you can have it also verify the types. Whereas in C++, because we don't allow it in the first place, if you try and compare two different types, it usually just fails anyway. So let's have a look at an example. We're going to have A, which is set to 3, it's an int. We're going to have B, also set to 3. If A is the same as B, then we will just print out, yeah, A is equal to B, A equals B. Is that it? Then we'll check if A is greater than 0. Well, yeah, A is definitely greater than 0. So in this case, we'll say that A is a positive number. Again, if for some reason, if we changed A so that it was 0, what would happen? If I change, say I change A to 0 up here, what's gonna happen? Correct, it will be false. So if were I to change A to 0, this wouldn't execute either because obviously B would be 3, so 0 does not equal 3. And this would also fail because 0 is not greater than 0. As it stands there, of course, this will run and this will run too. And of course we've got our usual return 0 and close the body of the function off. And you can see, obviously, to make it nicely readable, we've indented the code with some space so that you can see where stuff lives, right? So this is part of the if statement. This is part of the other if statement. This other if statement. So we indent stuff to indicate where it belongs, where it lives. So is that clear enough so far? Yeah, lovely. So. When you are writing an if statement, you can keep on going, as it were. You can try testing other stuff. So in the event that your if statement is not satisfied, you can add some more logic. So, for example, if if a equals 5, do whatever. But if for some reason it's not, then we can write else if, and then something else. So we could say, if a is greater than 5, do whatever. Else if it's greater than 4, do something else. And you can just keep on going, right? So if it fails, if this passes, if the first one, so if this happens to be true here, it will not look at this at all, right? As soon as it's satisfied, that's it. We're all good. So if this passes, we don't bother looking at this, right? We'll just stop. So is the flow of the logic clear there? Yeah. Cool.
Would it accept just else?
And you are correct. It would also accept just else. So if everything happens fail, then it will do the else. Similarly, you could put else if true at the end. It would achieve the same thing, right? Because it's guaranteed to work. And they are evaluated in the order that they appear, with it stopping and or sort of short-circuiting, as it were, once it finds one that is good and true. So as you've literally just said, yes, we can add an else statement so that we can do something in the event that nothing else is actually satisfied. So for example, if a equals b, then we'll do this. Otherwise, if a equals c, we'll do that. And if none of that happens to be true, we'll do this instead. Yeah. Cool. So, say we've got our greet function here, which takes a single parameter, right? This std string, which we're calling it name, doesn't return anything. So if someone calls our function and they give it Tom as the name, we'll print out hello Tom. Otherwise, else if the name is Ollie, we'll print out hello Ollie. So in the event they didn't pass Tom, we'll check if they passed Ollie instead. And if they did, brilliant, they will pass that. And if it's neither of those, we'll just say I don't know who you are. So this function is only aware of these two people effectively. Yeah, all good? And of course then we can use our function in main. We'll call greet with the name Tom, so obviously it's going to compare this to Tom, and of course it is the same, right? This does match this, so we say it's going to print out hello Tom. We're going to then put Stephen in. Well, no, Stephen doesn't equal Tom. Let's try the next one. Stephen doesn't equal Ollie. Okay, well then we'll go here. I don't know you. And then finally we'll turn 0 to exit from our program. Yeah. So we've got about 15 minutes, perfect. Another little exercise for you to do. So this one's working a little bit mathematically. There's something called the modulo operator in C++ and many other languages. And it's basically just calculating the remainder. So for example, if I do, in this particular case, 16 modulo 2, it's basically saying what would be the remainder of 16 divided by 2. So obviously 16 divided by 2 has no remainder, so it would be 0. Does that explain the modulo operator properly? Good, good, excellent. So, as ever, have a go at it. If you need any help, just holler. Oh wait, hold on. That's the example, isn't it? I need to actually get onto the actual exercise. Sorry. So everyone's clear on what modulo means first? Yeah, cool. There you go. That's the actual exercise.
Good, yeah.
What you got?
So I've taken int a. Now, if I take a and divide by 3, I get something
No,
that
you,
could be
you,
floated.
so if I show you the previous slide real quick, you don't need to divide. All you need to do is use the modulo operator, because that gives you the remainder, right?
Oh. Oh, so the modular if, okay.
If a number is exactly divisible by, if this is divisible by 2, then it's going to be 0. So all you need to know is does
I see.
it give you back 0?
Thanks.
For using
Yes.
multiple, I don't know what they're called. Does and work here? Yeah, that's fine. That's fine. Okay.
So I guess.
You could also do it by nesting.
Yeah, I was.
But that's,
I was going to ask if we're nesting.
No, if you know that, just basically
Okay, well, that should be correct, right?
Yes, precisely. Yes.
Now that since the average fits, is finished. And now you can choose this one. That is if you are not to use all the time, you don't need to use all.
And basically, in terms of just stylistically, would you put the following output below?
Similarly, well, we would try to do like everything like that. Every time you have a single problem, you could have because just from the idea of what happened in single means to a command is finished, next command. But you would put generally what's inside the scope, so it would not like very quick always a new line and then intent.
Or would you keep it first?
There are arguments about that. I'm the person who thinks, yes, keep it on that line. Microsoft further out and thinks otherwise. Yes, that's how I would do it. Like usually you would not put the query braces on the same line as you put the content braces. Just to make clear. If you want to really
Yeah, you could do it by nesting. But if you don't have a well, doesn't that don't give
But I mean,
any
you
reason
move
for
forward
that?
like that. But what they want you to do.
But if you want, give yourself a challenge, obviously, then.
Is it okay?
Mm. So you've got the correct things, but you've got them in the wrong order. So your if statements are in the right, they all do the right thing, but they're in the wrong order to do what you want them to. Because the problem you have, right, is that if it's divisible by both of them, it's never going to check that. It's just going to pass that one. So again, it evaluates them top down.
So first two will be evaluated, definitely.
No, only the first one will be. If it's divisible by both, it will immediately succeed on the very first if statement. It won't even consider the other two. They're just out of order, you just need to reorder them. Sorry?
something like that should be should work better.
Hmm?
Obviously.
No, your if statements. Well, I mean, try it and see what happens. If not. The problem you basically have is that one is unreachable.
Mhm.
That last bit's not reachable. Just need to reorder it.
So if you look at it without looking at the last
Change the order.
think about a number that is supposed to equal by 3 and by 5. Yes. Yeah. Now imagine traverse the function from top to bottom. See if you can reach the argument. You start with 15 to the top. 15. Yeah, correct. Is it true or false?
Is it correct minus if this or that?
No. So it was correct. It was already correct as is. You just need to move them around. The order of your if statement evaluation is the problem. Also, you've got rid of the else if, so that's not going to be correct at all now. But you need to reorder your if
So
statement.
this one comes on the top,
Mm-hmm.
but if it comes on top, there will be also a problem, because if this is
Oh, wait a second.
and, that means if the division by 3 is
Even more.
gives a 0, let's say,
Then it's both, yeah.
yeah, but let's say 9, we can divide with 3, but not with 5.
Then it won't pass that one, and that's correct. You want it to go to the next one. Why you have the else if, right?
Mm-hmm.
For an else statement, do you have to, does it have to be enough to?
We just need to follow on from
Further
this
one.
one.
Do I have to put an expression?
No.
So you have one more.
Get rid of the parentheses.
If one of these lines
It's the curly brackets, right? No, it's the regular ones. But we can.
There you go. Okay. Still not working? In function error, function definition is not allowed. No, you didn't close off your else statement.
I didn't.
No.
Well,
Okay, so if you want to look at it that way, you close off your else statement, you close off the function. Depends how you want to look at it.
Oh!
Okay. What? So I need a double?
No, just you need a matching number of closing curly braces as opening curly braces, and you
So
have one
double
less.
curly braces. 1, 2, 1, 2. 1.
They're good as one open to link out.
There we go.
Anything else now? Warning, no return. Oh, it's a warning. Okay, got 2 over. So 1, your fizz buzz doesn't. Is it meant to? So no, fizz buzz is meant to be boarded. It doesn't actually return.
Is that how it's supposed to look like?
Not void in, just void. Yeah. And then what's wrong with main? Oh, you've got a semicolon. You just need to fix your logic.
Something like this. As a if, not fizz buzz. Oh,
And if it's none of that, we don't do that.
just it's a mistake, I don't know how.
If it's none of them, then you put not physical bloody. Okay. We've just hit 9 o'clock, so I'm gonna have to wrap this up and very quickly show you the solution. So if you don't want to see the solution and you're still working, look away now. So we have our fizzbuzz function, which obviously doesn't need to return anything because it's just printing straight to the screen. It takes an int we're calling I. You can, of course, again, call this whatever you like. First of all, if it's divisible by 15, you can also optionally have checked if it's happens to be divisible by both 3 and 5. It's another way of doing it. But obviously this mathematically does the same thing, so this is fine. So if it's both 3 and 5, i.e. 15, then we say fizzbuzz. If that's not true, then we'll go down to this one and we'll check, well, is it divisible by 3? So i.e. if there's no remainder, then great, it's divisible by 3, we'll print fizz. However, if that's not the case either, we'll then go to check if it's divisible by 5. If that's the case, we'll print buzz. And if none of that happened, finally we'll say, well, it's none of those things, so it's not fizzy or buzzy. So I have no idea off the top of my head what these are. So 99, I'm going to say, well, that's obviously definitely divisible by 3, so I would guess that's probably fizz. 125 is obviously good for 5, I'm not sure if it's both. 225, definitely 5, I don't know. 1024, I'm assuming should be neither, right? So one of these two. Anyway, so you get the idea. This is how to use it, obviously. The important thing is this logic. So detecting both, detecting one, detecting the other, and then finally none of them. All right.
Yeah, we might be counter.
Sorry?
I get some error and I understand why.
No, I've got to wrap it up at the moment, I'm afraid. So, thank you very much, everyone, for attending. I hope, as ever, it's been informative, and as usual, we'll be popping to a nearby establishment for a beverage, should you wish to join us. And as usual, we'll probably end up talking about C++ and who knows whatever else happens to come up in conversation. Anyway, thank you again for attending, and hope to see you again in the near future. Cheers.